the charging port that still charges when your PC is off. Your computer is completely off, not sleeping, dead, and your phone is still charging from it. Most people blame the power strip. It is not the power strip. Every modern power supply keeps a 5-volt standby line active even when the system is fully shut down. This is called the S5 state. The machine is off, but the power supply hasn't fully cut current. Specific ports on your motherboard tap directly into this line. The feature is listed in BIOS as USB charging in S5 state or USB power share on Dell systems and must be manually enabled. The port connected to standby power is almost always marked with a small lightning bolt icon. If you have been plugging your phone into a random port, wondering why nothing happens when the PC is off, you are using the wrong port. The color code nobody told you about. You would think there is one universal standard for USB port colors. There is. Manufacturers treat it as optional. Black is USB 2.0, capped at 480 megabits per second. Blue is USB 3.0, also called USB 3.2 Gen 1, at 5 gigabits per second. Teal or lighter blue often marks USB 3.1 Gen 2 at 10 gigabits per second. Yellow means always on charging, staying powered during sleep and shutdown. Red typically signals USB 3.2 Gen 2 or a fast charge port depending on the brand. Orange appears on some boards for USB 3.1. The problem is none of this is enforced by the USB Implementers Forum, the governing body for USB standards. Two boards from different manufacturers can use the same color to mean completely different functions. Your motherboard manual is the only source that tells the truth. The port that can power a full monitor. One cable. No adapter. Display output, file transfers, and laptop charging simultaneously. This is DisplayPort Alternate Mode over USB-C, and most people have no idea it exists. When a USB-C port supports DisplayPort Alternate Mode, it reassigns some internal high-speed data lanes to carry a video signal. The remaining lanes handle USB data. Power delivery runs through separate pins on the same connector at the same time. The result is a single cable that outputs to a monitor, transfers data, and charges the device all at once. The catch is that most USB-C cables in circulation, including ones bundled with chargers, carry only power and basic data. They cannot transmit video, regardless of what the port supports. You need a cable explicitly rated for DisplayPort Alternate Mode or Thunderbolt. The port was ready. The cable from the drawer was not. The hidden data transfer speed most cables block. Your port says USB 3.1. The spec sheet promises 10 gigabits per second. You plug in a drive and get transfer speeds that would embarrass an old USB stick. The port is fine. The cable is the problem. All USB-C cables look identical regardless of internal capability. A cable wired to USB 2.0 specs caps your transfer at 480 megabits per second, regardless of what the port can physically deliver. Most bulk cables and box-included accessories are USB 2.0 wiring inside a USB-C connector. To reach 10 gigabits per second on a USB 3.1 Gen 2 port, the cable must be explicitly rated for that speed. Look for the Super Speed Plus logo on the packaging. If no speed rating is printed anywhere on the cable, assume it is the slow one, because it is. The port that can destroy your motherboard. USB was designed for convenience. Someone built a device that exploits exactly that. A device called the USB killer charges its internal capacitors from the standard 5-volt USB power supply. Once charged, a DC to DC converter amplifies that voltage and dumps a roughly negative 220-volt pulse back through the data lines of the host, repeatedly in a loop. Most consumer motherboards carry basic electrostatic discharge protection. Thin transient voltage suppressor diodes designed for small accidental static discharges, not deliberate 220-volt attacks. Without adequate protection, the pulse destroys the USB controller and often adjacent circuitry. Higher-end boards include resettable polyfuses and multi-stage surge protection. Check your motherboard spec sheet for USB over-voltage protection. If the spec sheet doesn't mention it, the protection almost certainly does not exist. The wake from sleep trick built into every USB. Your computer is asleep, drawing almost no power, and yet one key press wakes it instantly. The reason it can hear you at all is that the USB ports never fully powered down. During standard sleep, the computer enters what is called the S3 state. Nearly everything powers off, but the USB controller stays active, and the ports maintain a 5-volt standby signal. Connected devices use this to stay alive at a low level. When a keyboard registers a key press or a mouse detects movement, it sends a wake signal back through the live USB connection. In Windows, you control which USB devices can trigger this through Device Manager under each USB root hub's power management settings. If your computer wakes up at 3 in the morning with no explanation, a mouse detecting vibration or a controller sending an idle ping is almost certainly the reason. The charging speed that disappears after 1 meter. You bought a 100-watt USB-C charger. You bought a 2-meter cable to sit comfortably away from the wall. Your laptop is receiving 45 watts. The cable consumed the rest. Every conductor has resistance. Longer cable means more resistance, and more resistance causes voltage to drop between charger and device. USB power delivery automatically negotiates wattage based on what the cable can actually sustain, not what the charger is rated for. Wire gauge controls the ceiling, measured in American wire gauge values where lower numbers mean thicker wire and less resistance. A cheap cable using thin conductors at 2 meters cannot sustain high wattage without excessive voltage drop, so the negotiation settles lower. Quality cables rated for 100 watts at 2 meters use thick enough conductors to hold the full delivery. If a cable has no wattage and length rating printed on it, assume it has not been tested for either. The port running 4 protocols simultaneously. Every USB-C port looks identical on the outside. The one on a budget laptop and the one on a professional workstation use the same connector. Inside, they are not the same device at all. Thunderbolt 4 uses the USB-C connector but runs 4 protocols simultaneously: PCI Express lanes, DisplayPort video, USB 3.2 data, and power delivery, all at once, up to 40 gigabits per second total. This is how a single Thunderbolt dock replaces an entire cable setup. One connection delivers monitors, Ethernet, storage, and charging simultaneously. A standard USB-C port cannot do this. It lacks the Thunderbolt controller entirely. The only external indicator is the small lightning bolt icon printed next to Thunderbolt-capable ports. No icon means no Thunderbolt, regardless of what the cable or dock packaging says. The data port. That's also a secret debug tool. The same port you use to charge your phone has a second function most users never encounter. Engineers use that exact port to read raw system crash logs before the operating system has even started. This works through a protocol called UART, Universal Asynchronous Receiver Transmitter, a serial channel that many processors stream diagnostic data through during startup. If the device crashes before the operating system loads, that crash data is still flowing through UART. Engineers connect a USB to UART adapter, open a serial terminal, and read raw hardware output in real time. This is how Android firmware gets debugged, how router crashes get diagnosed, and how embedded developers see system behavior before any software is running. The port looks normal. What it outputs during startup is a different story. The speed limit. Your operating system puts on every port. Your USB hardware runs at its rated speed. Your operating system then quietly decides how much of that you actually receive. Both Windows and macOS apply USB power management that can reduce port performance. In Windows, a feature called USB selective suspend allows the operating system to put USB controllers into a low power state during idle periods, causing speed inconsistencies and reconnection delays, especially for external storage. To disable it, go to Power Options, then change Advanced Power Settings, then find USB Settings and set USB Selective Suspend to Disabled. On Mac OS, similar behavior affects USB hubs and drives. Disabling these settings will not deliver theoretical maximum speeds. Those are measured in lab conditions, but real-world transfers on regularly used drives will be faster and more consistent. The port that can be hacked without plugging anything in. USB charging stations at airports, hotels, and coffee shops look harmless. Security agencies have issued warnings about them. Standard USB connectors carry both power and data on separate internal pins. A malicious charging station, called juice jacking by the security community, can engage the data pins while appearing to supply only power. The connected device charges while the station attempts to establish a data connection, push malicious code, or access stored files. Both the United States Federal Bureau of Investigation and the Federal Communications Commission have issued public warnings about this attack. The practical defense: use your own charger and cable, or carry a USB data blocker, a small adapter that physically removes the data pins while passing power through. They cost under $10. You cannot juice jack pins that are not connected. The USB-C port that charges backwards. You know your USB-C port accepts charge. Some of those same ports can reverse direction entirely, pushing charge out to another device through the same connector. This is called reverse charging, enabled by bidirectional USB power delivery. When two devices both support power delivery in both directions, the protocol negotiates which acts as the source and which receives. Specific Dell and Samsung laptop lines support this. Certain Samsung Galaxy smartphones support wired reverse charging through USB-C as well. Connect a compatible device with a USB-C cable and the protocol handles direction automatically. Not every USB-C port supports bidirectional power. Many are receive-only by hardware design. The capability is listed in your device specification sheet under USB power delivery or reverse charging, the invisible handshake that decides your charging speed. Between the moment you plug in a USB-C charger and the moment charging begins, a negotiation happens in milliseconds. That conversation determines exactly how much power your device receives. USB power delivery uses two dedicated pins inside the USB-C connector called configuration channel pins. The moment the connection is made, the charger advertises voltage and current combinations it supports, typically 5, 9, 15, or 20 volts at varying amperage. The device responds with what it needs, and they agree on the highest compatible option. If the charger doesn't support power delivery, the device defaults to 5 volts at 0.9 amps, under 5 watts. This is why a basic charger connected to a 100-watt laptop will sometimes drain the battery faster than it charges it. The protocol found the floor and settled there. The port that remembers every device you've ever plugged in. You deleted the files. You may have even formatted the drive. Your computer still has a record of every USB device ever connected, name, serial number, and exact timestamps. Windows logs this automatically in the system registry under HKEY local machine, system, current control set, and enum. Every USB device that connects gets an entry with its vendor ID, product ID, serial number, and timestamps for the first and most recent connection. This lives in the registry, not the file system. Formatting a drive does not erase it. It survives until a full operating system reinstall that rebuilds the registry from scratch. Digital forensic investigators use this log to reconstruct exactly what devices were on a machine and when. A free utility called USB-DView reads this registry in a searchable format. Your computer has kept these records since day one. You just never knew the log existed. If port features run this deep, the colors on those ports are doing even more work than you think. That breakdown is already up. It is the next video. Go watch it.